In the previous video, we started to fill out a crib sheet of rules for calculating derivatives. The pattern we first derived was the power rule. In this video, we will continue to build up our crib sheet by deriving the so-called chain rule. The chain rule is a pattern sometimes useful for simplifying derivatives of composite functions. To understand this rule, it is important to provide the following illustration. Here is a plot of f on x versus x for a really boring function f. Here's a plot of g on y versus y, that is to say g on f on x versus f on x for a slightly less boring function g. If x takes on the value at the base of this arrow, then f on x is indicated by the golden marker. Draw a line to the corresponding point on the y-axis. G on y is the particular value that the function g associates with this particular point on the y-axis. Draw an arrow from g on y down to the z-axis. Arrows drawn in the xz plane point to a value of g on f on x for its associated x. Exploration along the x-axis corresponds to exploration along the y-axis, which corresponds to exploration along the z-axis. We want to demonstrate the chain rule, which says that the instantaneous slope d g on f on x dx at x equals x naught equals the product of the instantaneous slope d g on f on x d f on x at f on x equals f on x naught multiplied by the instantaneous slope d f on x dx at x equals x naught. This is painful to read aloud, and it is usually written and read dg dx equals dg df times df dx. If the animated markers explore intervals that are small compared to the geometric features of the plotted functions, then we anticipate that delta f over delta x is close to its limiting value df dx, and so delta f roughly equals df dx times delta x. This delta f is the same as the delta f on the triangle next to the pink plot of g on y versus y. And again, since the markers are swinging across small intervals, delta g over delta f is roughly equal to its limiting value. So delta g is roughly d g on f on x d f on x at f on x equals f on x naught times delta f. Substitute here for delta f the expression for delta f from the preceding line to learn that delta g is roughly equal to d g on f on x d f on x times d f on x dx times delta x. Divide both sides by delta x to conclude that delta g over delta x is roughly dg df times df dx. If the functions we are studying are boring enough, without really jagged edges, we anticipate that the rough inequality becomes arbitrarily good as delta x and the corresponding delta g become arbitrarily small. Hence, dg dx equals dg df times df dx, as we sought to demonstrate. The mnemonic for this rule is derivative of a function with an outside and an inside is derivative of the outside times derivative of the inside. The chain rule that we just derived helps us to obtain derivatives when working with functions nested sequentially inside each other. In the next video, we will derive the product rule, which is sometimes useful for simplifying derivatives of products of functions next to each other.